introduction, TC and Ann-Cathrine. I am very excited to be here. I try to set up this fancy thing where you can see me on the slide. Can you see me here in the little corner?
No.
You're not
Yeah.
sharing the screen right now. All we
Oh, I'm
Yes.
see
not
is you.
sharing my screen because
Yeah,
you should be able to see me here,
yeah,
Yes, we can
that
see
works. That
you.
works.
That's
You're in a
awesome.
but
circle.
I'm not sure that it's going to stay because it seems to disappear when I go to the next slide like this.
That's
So,
true.
I'll figure it out next time. So, thank you everyone for taking the time to listen to the things that I want to talk about today. A long-standing interest of mine has been what I've sometimes referred to as computational qualitative research. And that was back in 2015 in my dissertation. I used this term. And then eventually in a broader set of community that I'm part of with people such as Nick Birente, who was also from Case Western, also had the same advisor as me and TC, and Stefan Seidel, and Hani Safadi, Shaila Miranda, Natalia Levina, a number of other people. We started talking about computational theory construction or computationally intensive theory construction. And I think for me, this has very much been a movement of people who mostly come from a qualitative background, or at least from a background where developing theory is seen as of central importance. And I've been especially focused on this idea, like how can we imagine the work of researchers who come at research with a qualitative mindset but want to avail themselves of computational tools, of digital traces of various kinds, but still kind of keep that qualitative mindset. That has been the focus of a lot of the work that I've done, and that is what I'm trying to articulate today. This is early stage research, and basically it's a project where we're trying to figure out how to use word embedding models, and I'll explain more about them, to develop qualitative research and then extract theory from that. And we call it a conceptual blending approach to doing qualitative research using computational tools, a word embedding approach. And I'm going to get more into what we mean by this. Any comments that you might have or questions will be helpful. This is very early stage where we're trying to think through these things as we speak. This is work that I'm doing with two other co-authors. There's Philip Huckal from Copenhagen Business School, who is a qualitative researcher, and then there is Sammy Min at University of Minnesota, who also does qualitative research, but also has a computational bent. She was Natalia Levina's student at NYU across the river from where I am. So she's also growing out of the same community of people who have come from a qualitative tradition, but is trying to engage with computational tools in various ways. So the three of us are trying to pull this together. And what we've been trying to figure out is what is qualitative research once you disentangle it from the traditional tools that we use to perform qualitative research. So what I mean is this, the traditional view of qualitative research is that you do interviews and you transcribe those interviews, and then you do a close reading of the interviews through a technique such as, for example, grounded theory method, and you manually work with the textual data in order to develop theory of some kind. But that is a method. That is a way of doing this. And I think that there may be other ways of doing qualitative research. And this led us to the question of what is it that we're trying to achieve with qualitative research? What are the theoretical goals? And we came to an understanding that really what we're interested in achieving is to create theory about how people socially construct their views of the world, how they experience living in these socially constructed worlds and how they enact the socially constructed models that they have of the world and their experiences through engaging in various practices. So this is what we're interested in developing theory about. And what I'm trying to do here is to show how we can get at these aspects of social reality and human experience without necessarily using the traditional tool set that we associate with research trying to achieve these goals. And this is not necessarily a criticism towards traditional approaches to doing qualitative research. I see this as an expansion, a way of availing ourselves of new tools and new forms of data, which has volumes that we're not used to working with in a manual manner. And you'll see throughout this presentation that close reading of text by a human, meaning the traditional way that qualitative research has been done, is still essential to working with computational tools. We're not anytime soon getting away from that human-driven analysis of textual data to understand the qualities that are expressed in such data. It's still going to be there. Now, a traditional way of approaching this has been to say, like, well, but why don't we do mixed methods, right? So we can combine qualitative and quantitative. We've been talking about mixed method for at least 30 years, if not more, right? So this idea that you can use qualitative research and combine it with quantitative methods is definitely not new. In my mind, what characterized the mixed methods paradigm was this idea that you're mixing different ontologies, meaning views of what are the important things that exist in the world, and epistemologies, meaning our methods for gaining knowledge about those things that we think exist in the world and matter. And the qualitative and quantitative methods are derived from these different views of ontology and epistemology. And to provide a coarse classification of this, I would say that qualitative methods tend to examine intention. And these are things such as meaning, experience, construction, interpretation, some of the things that we just talked about in the earlier slide. And these are things that often are difficult to quantify and measure the extent of these phenomena. And that's where quantitative methods comes in. They help you examine the extension of social phenomena, things that you can measure in terms of how much, how big, how many. And those tend to be things such as behavior, the extent of clearly defined cognitions and effects of various kinds. This can be done through observation, but this is also traditionally done through survey research that allows us to measure people's cognitions and effects. And what we're trying to achieve here is something different, right? We don't want to combine different ontologies and epistemologies. And I don't think that given the new forms of data and analysis tools that we're looking at, that thinking of research methods as being divided between qualitative and quantitative is a useful way of thinking about research methods. And the reason I think that is that if you look at the types of text mining, natural language processing, and the most prominent example today obviously being large language models, the distinction between qualitative and quantitative falls apart, right? So is a large language model a qualitative or a quantitative method? Well, it obviously has a quantitative underpinning, but it's very much qualitative in the sense that it produces text that summarizes and expresses the mental constructions and experiences and interpretations of humans in various ways. So a large language model, for example, is very much both a qualitative and a quantitative method for relating to textual data. And I think that this breakdown between qualitative and quantitative method is just going to continue to break down. So increasingly, I don't think it's a useful way of thinking about what we're doing. Now, large language models are starting to make themselves into qualitative tools of various kinds. So this is Atlas TI, which is what I use. My understanding is that NVivo and other big qualitative analysis software also has the same types of functionalities. But in Atlas TI, you can apply a large language model. Sorry, that was my mouse went into the floor. Sorry. You can apply a large language model to your data set, and you can, in the manner of the way you interact with most large language models, you can talk to your data set. You can ask questions about your data set. And the large language model will then provide you answers with regards to what's inside of your data set and the various themes that seems to be present in your data set. And what's great about this is, at least in my experience, is that it seems to provide you with very powerful tools for summarizing data and identifying patterns which are obvious in the data. So for me, this is a useful summarization feature in certain types of situations. Those situations being where you're actually allowed to put the data in a large language model, which I think is increasingly becoming difficult to achieve unless you're using publicly available data. These models seem to do much less well with regards to providing novel insights into what's happening in the data and actually supporting the creation of theories that provides a new perspective on what's happening in data relative to what we've already learned from prior theory and empirical work. But beyond these issues of what the large language models seem to be able to do and not do with qualitative data analysis, I do think that their application is highly problematic because of the cloud nature of how these models are run, meaning it's not a simple algorithm that you can just upload in a repository for other people to apply on the data and get exactly the same results as you get. And also because of the black box nature of the ways in which these algorithms work, meaning it's very hard to understand at a detailed level why it actually provides the answers that it does apply. And that raises big concerns with regards to validity, meaning has the large language model actually identified something that does occur in the data, or is it a hallucination? It causes issues with reliability, meaning do you know that the application of concept identification, for example, is consistent throughout a data set? And it has issues with replicability. The standard that we had a few years ago for quantitative replicability was that you would upload your data set and then you would upload your analysis scripts, and anyone who would run those scripts on that data would get exactly the same statistical output. I don't think that this is easy to achieve using the generative AI tools that we have available today. So even if the summaries that you're getting from your data sets seem to make a lot of sense, my concern is that at present, the best we can achieve using the types of large language models that are built into Atlas TI, for example, is inspiration for your manual analysis. I don't see the rigor being there at this point in time. And I know a lot of people are working on trying to figure this out, both from a technical perspective, as well as from a theory development perspective. And I expect we'll see a large number of publications in the short and medium term trying to address these issues. And I think that's an important dialogue to engage in. But what we're doing is something different, right? So we want to achieve a rigorous and replicatable way of engaging with text in a computational manner. And there are multiple ways of doing that. Perhaps the most common way in which people have done this is topic modeling. And the thrust that we're taking here is what's referred to as word embedding models. And word embedding models are really useful because they offer a rigorous way of explaining what different concepts mean in a particular data set. I'm going to explain a little bit more about how that works. So the basic assumption of word embedding models is that meaning is relational. The meaning of a concept or the meaning of a word can't be objectively defined in terms of a definition. Rather, it can be best understood in terms of how it's relationally positioned in relation to other concepts and words. So this is the basic assumption between social field theory. So for example, Bourdieu has developed a theory of social fields where issues of power and cultural production unfold in social fields where people, concepts, and various forms of capital are characterized by the relational positioning to other people, concepts, and forms of capital. This picture here is an example from a book chapter where Bourdieu is analyzing French literature and different forms of French art to explain how different forms of art relate to each other and which forms of expression are more closely related to what other forms of expression, which allows you to understand the meaning of each form of art in relation to other closely related forms of art, right? So the basic assumption that we're working with here is that the meaning of concepts is fundamentally relational because social activities occur in a field where we're positioned close to some other concepts and people and resources and far away from others. Now, when you're looking at word embeddings specifically, word embeddings are semantic. So we're looking at words which appear in a corpus. And what word embeddings do is that they model each word as a vector, where the values of that vector describes how similar a word is in meaning to other words in that data set. So for example, here you have a word embedding vector space that's characterized by two vectors, two continua. One, which is the continuum between woman and queen, that's your y-axis, and another, which is the continuum between he and she, which is your x-axis. So here you can see how different words are projected on the space in terms of how they are related to each other. So the simplest word to understand here is probably queen, meaning that the word queen has a very high queenness and it has a very high she-ness, right? Because a queen is obviously a female royal. But you can also see the other words and how they kind of are positioned here. So you see that a king is very similar to a queen, but a king is also a he and not a she. And therefore you can see that it's positioned in the topmost left corner as opposed to the topmost right corner. And as you descend to lower and lower y values, you can see how the queenness or the royalty characteristic of these words decreases over time until you're at the bottom of the sort of queenness scale and you have the two words man and woman, which have very little queenness in them. But obviously one of them, woman, has a lot of she-ness and man has a lot of he-ness in it. etc., etc. And the same is true for all of these different words. The more you move right here, the more the word is associated with she, and the more you move left, the more it's associated with he, and the more you move upwards, the more it's associated with a royal position, such as queen, and the less with your gender, such as woman. And that allows us to understand these different words, not in terms of a definition, but rather in terms of their relational positioning relative to other words.
Ooh, and
So
before you move on, sorry,
sure.
there's one question in the chat, which was about why in that previous embedding graph, why is like daughter higher than mother, for example? And so if you could talk a little bit about interpretation here, because it seems like a lot of these are clustered and there's clear differences between woman and queen. Yeah,
Yeah. So
thank you.
oh, sorry. Well, the first answer is that I don't know, and my guess is as good as yours. I don't know why daughter and mother has this different, but I do think that if you look at words such as woman um, and mother, you could see you could suggest, for example, that queen is more likely to be a mother than someone who is just a woman but not a queen, in the sense that the queen might be older. Then, as you move up to heiress, heiress is more of a title, it's a female title, but it's not the same as a queen, etc. So you'll have a gradual difference as you move along these different scales, right? You will also see that you have words such as actor, where we don't necessarily think, per the definition of the word, that it has a clear gender aspect to it. But you could make the argument for this that relationally it seems like it's slightly more associated with he than she. And these words that are positioned here, they capture the patterns that are in the data set that the word embedding model is trained on, right? So these, what we see captured here are the biases, the associations, and the patterns that are present in the data set that we're applying the word embedding model to. So we may disagree with these normatively, and say we don't think it should be like that. We think actor should be completely gender neutral, for example. But this represents the patterns that we find in the data set. Is that helpful?
I think so, but yeah, there was some question about consistency, but I think you answered that with it depends on the text that you're using to train the model on. So
Yeah,
uh,
so I don't know what the quality of the text this is, and I'm not making an argument in any way whatsoever that these particular positioning is correct or more valid. But what I'm saying is that in relation to the data set that this space was, the algorithm was trained on to produce this space, here I think that these meanings are valid and accurate. All right. Well, it seems like this was a helpful explanation. And we'll also see how the fact that the different word embedding models could look different on when it's trained on different data sets is also a key for how we can use these word embedding tools for analytical purposes. So these conceptual spaces, they are defined by one or more axes that capture semantic continua between two concepts. So he and she, or queen and woman. And the positioning of a concept in the space that defines that concept in relation to other concepts. So normally we think of definitions in terms of you write out a set of words that defines what that word means. And here, the definition of a concept is its relatedness to other concepts to which it's similar. And what you can use this for is to, for example, characterize cultural phenomena, to understand how do human beings socially construct various types of phenomena. So this is another example of music styles, and these music styles have been projected on a space which is made out of the axis class and race. And you can see here how different types of music in the data set that this was trained on seems to be more associated with white or black culture, or between poor and rich class, right? So, for example, we think of opera as something that's more associated with white and rich, and we think of hip hop as something that's more associated with black and poor. And then you have other phenomena such as jazz, which are more central, but perhaps slightly more associated with rich and black, for example. So these map like this allows us to understand a particular phenomena in terms of how it's related to other phenomena. You can also look at how these spaces evolve over time to understand how our social construction of a particular phenomena changes across time. So here, for example, we're looking at the similarity with different words, meaning how close they are in space, to affluence. So we can see, for example, that education across the last 100 years has been increasingly strongly related to affluence, whereas other things such as morality have increasingly been less and less related to morality over time. And this is useful because it allows us to trace how our social construction of a particular phenomena changes or evolves across time. So that's a very, very basic introduction to what word embedding models are and what they can do. And what I tried to achieve at the outset of this exercise is to explain how do we build theories using word embeddings. So that's what we're going to try to look at here. So to understand how we can build theory, and not only theory in general, but theory that is novel and interesting and useful for understanding the social world, we're going to draw on a set of concepts from cognitive science called blending theory. And blending theory also uses this idea of conceptual spaces where concepts exist relationally to each other. And what blending theory tried to explain is how is it that human beings can be creative in their thinking? Why do we not always think the same thing over and over again? How can we create new ideas, which is what theory development is, creating new ideas to better understand the world. And what blending theory posits as its explanation for how we create new mental representations of the world is that we blend multiple spaces of concepts together to create a hybrid of those spaces, which provides new concepts out of old concepts, which provides new configurations of old concepts. And that is the way in which we create new ideas. So, for example, let's see here, I'm going to have. You could imagine a generic space which provides the basic concepts that we're dealing with. So this is what sets the context of a conversation or a creative process. So consider the gig economy, where people are not full-time employees, but they take on short-term gigs for compensation. We can then imagine two specific input spaces that are related to that generic space, which are mobile apps and taxis. And if you merge mobile apps and taxis together, you get an idea or a company such as Uber. So Uber was a novelty when it was launched. It was something completely new. But from a blending theory perspective, you would make the argument that it's not created new out of whole cloth. It's a novel combination of other concepts and ideas that already existed, and when they were put together in a novel manner, that helped to create a new business model, a new idea for how one could take a taxi, not through a taxi company, but rather through a mobile app that facilitates a relationship with another private individual. So the idea is that we can interrelate multiple conceptual spaces with each other in ways that create new concepts that may help us to explain the world in new ways. So to show how this can be done with word embedding spaces, we've created 5 of what we call theorizing moves. And these are 5 different things that you do as you work with word embedding models in order to create new theory. So this is not the same thing as something that I would call analysis steps. So we're not talking about data collection. We're not talking about how to write the code for the word embedding models in R or Python. We're not talking about the statistics of how we achieve these things, but rather how we use the method of word embeddings to create new theories. So in that sense, this is less a method paper and more of a theory development paper using a particular computational method. The first thing that you need to do when you want to work with word embedding and semantic spaces is to construct the spaces. So the spaces are not induced from the data set. They're not like topic models where you just ask the algorithm to provide you a view of what's in the data. You as the analyst have to construct the space in terms of deciding what are the different axes that you're interested in. And in general, I think you would be working with 1 to 3 axes. You could have a single continuum, such as on the right-hand side in the topmost part of the figure. In A, you're just projecting words on the single continuum of class understood as affluence. Most of the times, word embedding models are probably going to have 2 axes. You could also imagine you have 3 axes, meaning you have some type of height, so a 3-dimensional space. In principle, you could have any number of dimensions in a word embedding model, but at some point it becomes cognitively intractable to add more axes. So I could imagine, for example, you could have 4 dimensions. You could have a 3-dimensional space, and then maybe you use the coloring of the words or the size of bubbles that are positioned inside of that 3D space to express 4 dimensions. But I think at some point, as you start to reach 3, 4, 5, 6 dimensions, it becomes so difficult to think about what such spaces look like and what they mean that it becomes difficult. So in our work so far, we've mainly worked with 2-dimensional spaces because it easily becomes cognitively overwhelming after that. It's not a computational constraint, it's a cognitive constraint. So you have to choose the continuum, and you have to choose both the polar ends. So if you remember the prior figure, the polar ends were not necessarily the most intuitive. He and she seems to be clear opposites, but woman and queen are not opposites, but they still denote a continuum meaning where something can be more associated with woman and something can be more associated with queen. So you have to define each of the ends of each of these continua. So there's a considerable amount of creativity that comes into defining what these polar ends look like based on what your theoretical intent is. What is the phenomena that you're actually interested in analyzing? Once you define the polar ends of the continua that you want to use for your space, you also have to pick the words that you're going to project into that space. So all of these things are theoretical choices, which means that you want to be guided by prior theory or prior empirical work. And practically speaking, I think a lot of times this requires close reading of the data, meaning that even if we want to work with computational tools to perform qualitative analysis, you're still not going to get away from the need to engage with the data on a manual human level through reading it and thinking about what it means and what's interesting about that data. Because most of the time, I think that's going to be what provides the basis for deciding the polar ends of each axis, as well as the words that you want to project onto that space. So once you've constructed your spaces and you've projected the words, then you're going to engage in an iterative process of modifying what those continua look like, adding or deleting axes, reformulating the continua of axes through changing out what the polar ends look like. And you may also want to formulate multiple spaces which together may tell a rich, coherent story, right? So it's not necessarily that you're going to have a single space for your entire paper. You may have multiple spaces for different units of analysis, different organizations, or you may temporarily bracket the spaces so that you're looking at how something evolves over time. So a lot of the theoretical work is about modulating the dimensionality of these spaces to figure out which set of spaces are the most suitable for understanding the phenomena that I'm interested in inquiring into and how that is expressed in the particular data set that you're using. Third, you may want to interrelate multiple spaces. So it could be useful if you want to look at how something is socially constructed across more than 3 axes, rather than creating a 4, 5, 6-dimensional space that becomes impossible to think of. You can superimpose the same words on multiple spaces with different axes, or you could use the same axes and position different words on those differently configured spaces. And this can be really useful if you have, for example, a really complex phenomena that you want to analyze. If you want to trace evolution over time across that phenomena, you may need to use multiple spaces. Or if you have multiple units of analysis or different cases that you want to compare to each other. Or as in the example on the right here, if you're doing a multi-level analysis, you may want to use different spaces for each of those levels, using different data sets, and then compare them to understand how a phenomenon unfolds at different levels of analysis. So you're going to need to use multiple spaces unless you're working with a very simple phenomenon in order to provide a rich characterization of what that phenomena looks like when expressed through the language of multiple interrelated word embedding spaces. Now, once you've identified the different spaces that you want to use and the words that you want to project on them, then you can start to analyze the position of words which represent concepts in those spaces. And what you'll be looking at is clustering, meaning what are concepts that are close to each other. So according to this word embedding model, you see that techno, bluegrass, and punk seems to be concepts that are closely related to each other, and that seems to tend to be more white and poor on this continuum. And you can also see that there are other types of concepts that seem to be very, very different to each other, meaning that they're distinct and largely unrelated, such as opera on the one hand and hip hop and rap on the other hand. And analyzing clustering and distances will help you get an understanding of what these words mean in relation to other words and how they are positioned together or not together in a particular word embedding space. And again, I think that this is best done through a close reading of a text. And I think in the particular example, I think most of us looking at this, we have our own lived experiences of music such as opera, techno, and hip hop. So it becomes easy for us to think about why these things would be associated in the way that they are. In many of the types of research analyses that you will be doing, you may not be looking at concepts that you have such a sort of lived experience of, such as different music styles, which are part of more or less all of our lives. You may be looking at specific IT-related concepts, digital concepts of other kinds that may have unique meanings in the data set that you're looking at that may not be intuitive to you at all. And then in order to understand why they're positioned the way they are in a particular space, well, then you will need to do a close reading of the text that forms your data, so that you can develop theory about why some words are related to each other, why others are not closely related to each other, and why they're positioned where they are in the spaces that you have created. And the last step is that you need to provide some type of leap of faith model construction, right? And this is where we depart the most from the analytical manipulation of the word embedding spaces. At some point, you need to abstract from all of the word embedding spaces that you've created throughout your analysis and create some type of model. And here I am showing a process model. And this is definitely not the only type of model that you could create using this. It could be boxes and arrows. It could also be things such as design principles. It could be a linguistic formulation of causal mechanisms. It could be linguistic formulations of mutually constitutive relationships that characterize a phenomenon that you're interested in. So it could look in many different ways. But what's common to all of these is that they cannot be directly deduced from the analysis. There's like a slight leap of faith that you have to take to formulate a model that helps to tie together all the different observations and analyses that you've conducted using your word embedding models and explain why those patterns occur in some type of high-level abstract model. So yes, on the one hand, you're transposing analytical displays. Those are the word embedding spaces to constructs and theoretical relationships between the constructs. So that's where the grounding of your model, your theory is in the word embedding spaces. But you're also going to be a bit more speculative. Your model is going to provide suggestions of the mechanisms which may drive the patterns, which may explain why are different things related the way they are in the word embedding spaces. And also the theoretical model that emerges from this is just not, it's not only a thematization or a summarization of the data, right? That's what the large language model can do for you. The large language model can summarize what you have in the data. But what we're trying to do here is not just to describe the data at a high level of abstraction. We're trying to create a theory that explains the patterns in the data better or from a new angle or in a more interesting way than theory that already exists. So when you're in this leap of faith model construction process, you're constantly comparing the emergent theory, the theory that you're creating, to extant theory that already exists, so that you can provide a new perspective of things. And this is where a lot of the creativity comes in to doing this type of work. And you're trying to do this in such a manner that you can make a theoretical contribution, meaning that you can create a new way of explaining the world so that we can see the world in a way which we couldn't see the world before your research, before your theoretical contribution, which then makes a contribution to the discourse, to the scholarly discourse, and a contribution, in my mind, is an understanding that is a tool for other scholars to ask new research questions, to do new forms of research that weren't really possible before your research had happened. Meaning that all of us stand on the shoulders of giants, right? We see what we can't see because of the work that prior scholars have done before. So your contribution must then consist in providing a set of shoulders for scholars who publish after you, or for yourself in your next publication, that enables you to see further, see things in a new light, understand something new based on the research that you've already done. And that's very different from providing a summary of the data sets. So I am hoping that this approach to theory development using a fairly novel set of methods, meaning word embedding models, can mobilize new forms of research, that it can provide a set of shoulders for myself and for my co-authors and for other researchers in our communities to stand upon, so that they can do new forms of research, so that we can understand the world in ways we couldn't without this. And I think it mobilizes a number of different types of research. So first, I think you can get a very good view of how different social constructions, different worldviews are mutually constituted through looking at how different concepts that make up such a social construction, how they're related to each other. This can provide very rich and rigorous depictions of how a particular worldview or a particular cultural phenomena, how it's constituted. So that would be the equivalent of a single case study. The second thing that I think this can do is to provide rich and rigorous views of cultural and discursive evolution, meaning how do such understandings of particular words, how do they change over time? And you would do that through temporally bracket different periods in the data set and then fit different word embedding models onto different parts of the data set and then show how they change over time. I also think so this would be a longitudinal case study. And the third is that you can compare multiple life worlds or compare different views of the world with each other. So that enables comparative case studies where you can look at multiple cases to see how do they understand the same phenomena in different ways through using different data sets. And overall, I think that this can also provide a complement to traditional qualitative close reading. Traditional qualitative close reading is great at arriving at a rich understanding of a particular phenomena, and it enables us to engage the inherent creativity of the human mind to create novel views of the world. I think that close reading can struggle more to show that it's rigorous because it's hard for human beings to apply heuristics in a consistent manner. And I also think that close reading seems to scale poorly with very, very large data sets. And I think that this distant reading approach, which is what we're talking about here, can allow you to use very large data sets, and it can also provide a degree of rigor to your close reading. I think one of the key messages here is that as long as we're working with text, as long as we're working with culture, and as long as we want to create theory that has a degree of richness to it, we're never going to get rid of the close reading part of this theory development process. You're always going to be doing this, but there is added value of using computational tools such as word embedding models to this. So this is all that I have for you. This is what me, Philip, and Semi are currently working on. I hope it's been useful, even though it's pretty bare bones at this point. And I would love to have any questions or comments or reflections, whatever you have. I think we have another half an hour, so feel free to raise whatever thoughts you might have.